Okay, so you asked about two questions, I believe, number 3 and 17. So I have number 3 up right here. We're just going to go through the example that we did in my office hours. So let's see. We have 3 samples. We're going to do A, determine the estimator, population, standard deviation. Okay, so there's 3 different notations we need. This is our sample, standard deviation. We have sigma, which is the population standard deviation. And then we have sigma x bar, okay, which is the sampling distribution standard deviation. I'm just going to call the standard error for now. Error. Okay. So right now what we want is the estimator of the population standard deviation. What I'm trying to do is I'm trying to estimate this thing right here. And the way we do it is we have a few formulas. We have this one here. Okay. Where's my mouse? This here, the estimator, that's this. Okay. So what happens is you're given the sample standard deviation and you're able to calculate the population standard deviation using this formula. And all you need is the sample size, which we have, it's 6, and standard deviation, which we have to find. Now you can do this the hard way, where you can find the mean and the standard deviation of this set. Right now I have my calculator set up so that we can figure this out quickly. So I have the numbers already in the list, and then I'll just generate the information. So okay. So my mean is 6.1666 and so on, and then this is my standard deviation. And remember, we always use this one when doing it in the calculator. So 4.947. Okay. So S is 4.947. Again, this is for A. The mean was 6.16, but unless you're using the long formula for the standard deviation, you don't need to know the mean. Alright, so that's my standard deviation. My N is 6, so then you would use this formula, which is 4.947 square root 6/5. And then we would plug that into the calculator. So we have 4.947 times root. Okay. So I get 5.419. 5.149. Okay, so that's how you would do it for set A. You just repeat it for set B and C. The numbers are big, the set size is bigger, but you still follow the same steps. Now for part B, what it wants is sigma x bar. You see the little hat there. Ignore the hat. Just we want to find this, which the formula for this, there were 2 of them. You can either have this formula or this one here. Now this one is when a population size is given. And according to the problem, population size is given. So all we would do for set A is we would plug all our information into this. So sigma, which we just found in the last example, over the square root of n, which is 6, 800 minus 6, 800 minus 1. And you'd go ahead and calculate that out. Let's do that real fast. Oops, gotta turn it on. Alright, so I get 2.214. 2.214. And there you go. So you repeat the process for set B and C, and it should be the same. Alright, moving on to your second question. Where is my mouse? Okay, number 17. Now, we did a problem like 17 in class, so I want to show you from the lecture notes, which that's not it. Okay. So these are my section 5 lecture notes. And where is it at? Okay. It's the one with the Money magazine, 2002. Notice that it's, where is it? Okay. It says 1144 out of 2600, so the mean is a proportion, and we figured it out here, a proportion, which is 44%. Now all of this, what we did here, is exactly what you do for this problem. So I'll just kind of start you off with it, but notice that what you need to do is this formula here. And in order to get this formula, you need a lot of stuff, which is all done in here. So let's take a look at this. So we need the mean, which is 960 over 1500, which what is it? It's 64%. Okay, I'm actually do this in percents. And we know the confidence level, so we can find Z. What else do we know? Okay. What we need is this. Our goal here, by the way, sorry, it's not mu. That's x bar. We want this. This is our formula that we want. Now we know n is 1500. I don't know sigma. Okay, so that's my goal. Now, if you follow the example from the notes, in order to find sigma, we needed to find the standard deviation of this table here. So if we set up a table where the people who agree, we give the number 1, and then disagree 0. Now 960 agreed, and so 540? Okay. 540 disagreed. Now if you did the mean, which we already figured out, it would be 1 times 960 plus 0 times 540 all over 1500. That's 64%. So I already knew that, which I'll write as a decimal actually. And the standard deviation, which is S, by the way, because we're finding it from a sample, we got to use this nice long formula. Now, what we're doing is we're going to do 1 minus 0.64, but we're going to do that and square that. But we're going to do that 960 times. Then we're going to do 0 minus 0.64 squared, but we have to do that 540 times. You know, all multiply all that stuff out, add it, and then divide by 1500. All right, you're going to get a number here. This number is S. Well, you need to find sigma, which uses this formula. And then after you find sigma, you need, well, then you have everything actually, because you'll have x bar, sigma, you'll have your sample size. The only thing you have to do is find the confidence level, but I'm not sure if you have issues with that. So hopefully this example helped. And if you have any questions, again, just send me an email. Oops. sorry, I did make one mistake. The formula you're using is this. I forgot the z. Okay, so this is the correct formula right here. Again, forgot my z. So once you find z, which is going to probably be 1.7, something like that, you would plug that in for z. So sorry about that. So if you had watched this, nothing changes out of all of this. Just when you do the final answer, just make sure you have that z in the formula. Okay, thanks.